Hello and welcome back to IBDP course, and today we are going to discuss the solutions as well as the concepts, right, asked in IBDP MAA SL paper 1 zone 2. Students face problems while applying those concepts into the question. So here I will explain each and everything and I'll try to make it easy for you. If you have any other doubt or any question that you want to ask, feel free to connect with us using this WhatsApp number or Telegram channel. And if you want to join our course, you can contact us using the same WhatsApp number. Okay, so let's get started. This is paper 1 held on 15th May 2025 and for 80 marks in total, where GDC is not allowed for paper 1 for MAASL. Okay, so here is the first question. Consider the function fx equals x raised to the power 3 plus 5x squared minus 8 and f prime 1 is to be calculated. What that means? F prime means first you need to find the f prime x and then you have to substitute x equals to 1. So this is the method or approach to simplify this question. And here I will use this derivative formula which says derivative of any x raised to the power any number n, where n can be any real number. Okay, it is n times x raised to the power n minus 1. Just reduce one power, as well as the derivative of constants, right? What is the derivative of any constant number? Always 0, no rate of change. So f prime is to be calculated. We have the fx as x to the power 3 plus 5x squared minus 8. So let's find the f prime x first. So f prime x is equals to, use the derivative formula for x cubed only. So what is that? It is 3 comes out, x reduce one power of x. So it will become 2. Now we have this 5 x squared, 5 as it is, then 2 comes out from the power and reduce one power of x. So it will become 1 power. So 5 times 2 is what? 10. So simply I will write it as 10 x. Now for the constant number 8. 8 is constant, right? So its derivative is going to be 0. So here simply write 0. So that's the derivative. Okay. Now I'll remove this 0. No need to write that. So this is the derivative. Now the second part is, it says find the derivative when x equals to 1. Means we have to find the gradient of the tangent line at this point x equals to 1. So simply substitute x equals to 1. So in place of x everywhere put 1. So 3 times, it is 1 squared plus 10 times 1. Now simplify it. What is that? 3, 1 squared is 1 times 3 gives you 3 plus 10 times 1 is 10. So 13 is the value. That's it. Now for the B part. It says find the equation of the tangent line to the graph of f at x equals to 1. As I said, f prime 1, what is that? It is the slope of the tangent line at x equals to 1. Slope of tangent line. Okay. When x equals to 1. Now we have to find the equation of the tangent line. So I will use the equation of line given by y minus y1 equals m times x minus x1. Either you can use this, where x1, y1 are the coordinates of any point lying on the line and m is the gradient or the slope of the line. Okay, it is for any line. It is the equation of line. You can also use y equals mx plus c as well. Okay, that will also work, but it makes it lengthy, so I'm not going for that. So what is the value of x1? X1 is simply 1, already given. What is y1? Y1 is the value of y when x equals to 1 in the original function. So first we need to calculate that as well. Okay, so in the original function over here, just put x equals to 1. So that gives me 1 cubed plus 5 times 1 squared minus 8. What is that? Simplified. So we'll get 1 plus 3 minus 8, right? 4 minus 8 gives minus 4. So yes, we got the coordinates of one point lying on that line. So that point is 1 comma minus 4. Now we have to find the equation. Okay, so y minus minus 4 equals m, means the gradient. What is that? It is 13. So put it as it is, times x minus x1, means x minus 1. What is that? It implies y minus of minus 4 will become plus 4. So it means y plus 4 equals, it is what? Multiply this 13 with each term in the bracket, means 13x minus 13. When this 4 goes to the other side, okay, it will become negative 4. So the equation is y equals 13x minus 13 minus 4 makes minus of 17. And that's the answer. So I hope you got this right. Now, next question. It says the derivative of the function g is given by g prime x equals cosine x plus e raised to the 2x, where x belongs to real number. Given that g of 0 is equals to 7, find the gx. Here, derivative itself is given and they are asking for the original function. Means we have to integrate this function, obviously, right? Because if we integrate any function, let's say f prime x dx is given, so its integration is going to be the fx plus c, where c is any constant of integration. In order to find that c or constant of integration, I have to use this initial value problem over here. What that means? This means that when x equals to 0, then the value of g will be equals to 7. So that helps us to find the value of this constant of integration c value. Okay. Once we get this c value, we are done. Okay. So let's use this g prime x, which is given, equals to cosine x plus e raised to the 2x, and integrate both sides. Okay. So when I integrate it, what I get? I'll use the formulas, and the formulas are already given to you in your formula booklet. Okay. So just integrate both sides, integration on both sides. That gives me, we have to integrate both the functions, basically integration of cosine x dx plus integration of e raised to the 2x dx. Now, integration of cosine x, what is that? Sin x, simply sin x plus, now for e raised to the power 2x, e to the power a linear function, right? So you can go for the substitution, or you can directly use the formula e raised to the power 2x divided by 2. That's the integration, but we have to add a constant of integration plus c as well. So this is the value of g of x. But here we have unknown c, so we have to get rid of that and we have to find the particular value of that c. For that I will use, as I said, the initial value problem, means put x equals to 0 and g equals to 7. So let's see what we get for the c. So 7 is equals to sine 0. Sine 0 is 0. E to the power 0 will become 1. So plus 1 by 2 plus c. So hence we got the value of c as 7 minus 1 by 2, which is 13 by. So we got the particular value of c and hence the solution. Therefore, the final value of g of x is coming out as sin x plus e raised to the power 2x by 2 plus 13 by 2. That's my final answer. Okay. Formula for cosine x integration is sin x, and formula for e raised to the power any kx, if you have to integrate it, kx plus let's say any other constant m is given to you and you are integrating it, its integral is simply e raised to the power, that same linear part, kx plus m, divided by the coefficient of x, which is k in this case. This has to be linear, okay, then only you can apply it. So next one. Now fx is given by this 3x minus 2 over 2x plus 1, where x is not equal to negative half, obviously, otherwise the denominator will become 0. Okay, first part is find the value of f of 0. F of 0, what that means? It means simply put x equals to 0 in the original function. Simple. So let's calculate that. So f of 0 will be equal to, put x equals to 0, it means 3 times 0, which is 0, minus 2 divided by 2 times 0 plus 1, right? What is that? Negative 2. So this is the answer for the first part. F of 0 is 2. What that means? It means when x equals to 0 means this point. When x, no, when x equals to 0 on the y-intercept, then what is the value of y? It is negative 2. So the coordinates of this point are going to be 0 comma negative 2. Okay. Next, write down the equation of the horizontal asymptote. For finding the horizontal asymptote, you can use the concept of calculus or direct formula. Okay, I'll give you the both. See, for the horizontal asymptote means your limit x must approach to infinity. Okay, plus infinity or minus infinity, both you can take. So for that fx, that gives you your horizontal asymptote. So here, if I apply that limit x approaches to infinity for this 3x minus 2 over 2x plus 1 using the analytical methods, or you can use L'Hopital's rule or any other method you want, right? So what do you get? You will get it as coefficient of x from the top, which is 3, divided by coefficient of x in the bottom, which is 2, because it is linear over linear. That's why this is the value. So y equals 3 by 2 is the horizontal asymptote. It's a line passing through this y equals to 3 by 2. This point is what? 3 by 2. There is a line which supposed to touch the curve at infinity. By the way, it is not touching or cutting our curve, but supposed to touch, okay, at infinity. Now, we got the range. Okay, next part. So y equals to 3 by 2 is the horizontal asymptote. It says the function g is defined by gx equals to minus fx. What is the meaning of that minus fx? Means all values of f will become negative of its original for the same values of x now. It means you are taking the mirror image about x-axis. That's it. Mirror image of the original function about x-axis. Okay. Let's take the mirror image about x-axis. So I'll use the different color. But it says for x greater than or equal to 0 only. So I'll not take that part where x is negative, okay? I'll take only that part where x is greater than or equal to 0. It means right side of this y-axis portion. So take the mirror image. Means what are the coordinates of this point, by the way? Here the y value is 0, so you can calculate the x value also. Okay, but this point is as it is over here. Now take the mirror image about x-axis. So it goes up. This part goes up to positive 2. So this goes up top up to this positive 2. Now, okay. Now for second part, means for this portion. For this portion, take the mirror image about x-axis and you will get the graph comes out as this. Okay, this one is the graph. Okay, I hope you got this. We are just taking the mirror image of this portion about the x-axis on the right side of the y only. Okay, so what is that? We know that this branch goes maximum up to this 3 by 2, right? Maximum up to that 3 by 2. So on the other side, means downward side, again it will go up to what? Negative of that 3 by 2, right? So here I can simply say that the minimum value that it can reach, I'm not saying exact value, but open, because here for your minus g of x, which is blue colored graph, this is minus 3 by 2, which is the minimum value for that g function, because we have to find the range. Okay, means graph takes y values more than this minus 3 by 2, and what is the maximum? Maximum reaches up to this point. What is that? It was 0 comma 2, right? It is mirror image of this 0 comma negative 2 actually about the x-axis. So 0 comma 2. So negative 3 by 2 to 2. This is the range, not x, sorry, y. This is the range of g. So our g function basically lies between minus 3 by 2 to 2. This is our answer. If you still have any confusion in it, feel free to ask me in the comment box or to this number. Next one. The following diagram shows a non-right angle triangle ABC, and this non-right angle triangle is given to us, and these are the information. By the way, informations are already marked on the figure as well. So first part says using the sine rule. What is the sine rule? Sine rule is also given to you in the formula booklet. Okay, it says if you have any triangle ABC, then sine A over A, sine B over B equal to sine C over C. So here I can say, if I use the sine rule, sine of angle, let's take angle A. So what is the angle A, by the way? It is 2 theta, right? So this A is actually 2 theta divided by side opposite to that, which is 6 root 2. Okay, this side is BC. So in place of A, I can write 2 theta also. So let's write 2 theta over here. Next, equals to, take another angle, say sine C. What is the value of C? Theta. So sine C over the side opposite to this theta angle is what? 5 units. So sine theta over 5. This equals to sine B over this AC side, but these are not given to us, so I'll not take that. By the way, this is also equal to sine B over this AC side length, but we don't need this, right? This time we don't need this, so I'll erase it. Next, sine rule you have to use. We used it. Now we have to show cosine theta is 3 root 2 by 5. Let's apply this. So here again I will use the formula for the sine 2 theta angle half formula that also provided to you in your formula booklet. It says sine 2 theta is 2 sine theta cosine theta. So apply it. So numerator part of this will become 2 sine theta times cosine theta divided by 6 root 2 is equal to sine theta over 5. Okay, now simplify it. I can cancel out this sine theta with this sine theta, right? And this gives me cosine theta equals, this goes to that side and goes using the cross multiplication basically. 6 root 2 goes to the other side divided by 10, right? Now 6 and 10 have a common factor of 2, so I can write 3 and 5, and hence the cosine theta value that we have to prove. So cosine theta is what? 3 root 2 over 5. Proved. First part done. Now B part. It says also find the sine theta. Once we got the cosine theta, we can also find the cosine theta. So we can find the sine theta using the cosine. Using this identity, sine squared theta plus cosine squared theta is equals to 1, right? Trigonometric identities. So cosine theta is already known to us. Just substitute, plug in the value of cosine theta in this, and we can solve for sine theta value. So let's apply that. So I'll get using this sine squared theta plus cosine squared means I have to take the square of this quantity. What is that? 9 times 2 because 3 squared is 9. Root 2 squared is 2 only. 2 divided by 5 squared is 25 equals 1. So from here we can simply find the value of sine theta. That's it. So sine squared theta is 1 minus 18 over 25, which is, take the LCM, 25 minus 18, right? So I'll get sine theta is equals to, so I'll get on the other side, I'll get 7 by 25. So if I take the square root also, I'll get square root of 7 by 25. And since it is given that theta is lying between the 0 to pi by 2, it means theta lies in first quadrant. So that's why I'm taking sine theta as 7 by root 25, which can also be rewritten as sine theta equals root 7 by 5. Okay. Now the next part. Next part says D is any point lying on AC. So let's take any point over here. It is D point. Now form the triangle BCD, this triangle. And now it says the area of this triangle BCD is what? 2 root 14. Hence find the length DC. We already know what is the formula for finding the area of triangle, right? Half two sides. You can choose any two sides A and B times sine of angle between them. Okay. So this is the formula for area of triangle ABC, where these symbols have their usual meaning. Universal notations are used here. So now here I have to take the triangle BCD only. So in this triangle BCD, I will choose any two sides in which one of the side must be DC because we have to find DC value. So take the DC as well as BC side. So I'll choose these two sides and sine of angle between them. What is the angle between them? Theta is the angle between them. So I'll use sine theta over here. So for this one, last one, the answer will be half of 6 root 2 side lengths, right? Product of side lengths will be 6 root 2 times, what is that? DC, missing side length, that is to be calculated, times sine of angle between them. So sine theta. And we already know the value of sine theta, by the way. This value is given as 2 root 14. So plug in 2 root 14 on the right side. Now sine theta is also known. Plug in that sine theta as root 7 by 5 and solve for DC. So this cancelled with 3 times. So we got 3 root 2 times DC times sine theta, which is root 7 by 5 equals 2 root 14. Okay. Now root 7 and root 2 will become root 14, that can be cancelled on the other side. So what is the DC value? Now use the cross multiplication. Okay, simply use the cross multiplication. We got 10, 5 times 2, 10 divided by 3 as the value of this CD or DC. That's the answer. Okay, so in this way we can find the side length or the missing side length using the area of triangle formula. Area of triangle formula is simple. You have to choose any two sides and you have to take the angle between those two sides only. So half product of those two sides times sine of angle between them gives you the area of triangle. It works for any triangle. Okay. Next one. The quadratic equation x squared plus kx plus 15 minus k equals to 0 has two distinct real roots. Find the value of k. It means it is related to the discriminant, right? You already know, you are already familiar with this, that we can find the nature of the roots of a quadratic by finding its discriminant. If we have ax squared plus bx plus c as our quadratic equation, okay, then we can find the discriminant d equals b squared minus 4ac, right? If d is greater than 0, roots are real and distinct, okay, real and distinct. If d is 0, means discriminant becomes 0, then roots are real but equal, real and equal. But if the discriminant becomes negative, then roots are imaginary or complex root, I'll say. There is no real root. Okay, complex roots are there. So in this question, they wants us to find the value of k for which the roots of this equation are two distinct real roots. Distinct real, it means discriminant must be greater than 0. Let's find the discriminant corresponding to this. So here, what is a? A is 1. If I compare the given equation with the general form, a becomes 1, b becomes k, and c is 15 minus k. Right? That's how we can relate these. This is c, this is b, coefficient of x squared a, which is 1. Now we have all these values. So let's find the discriminant and put it greater than 0. So we get b squared means k squared minus 4 times 15 minus k times 1. Simply b squared minus 4ac. This quantity must be greater than 0. So you just have to solve this quadratic inequality only. So k squared, when I simplify it, it will become plus 4k, right? 4k and minus 60 greater than 0. Now you can factorize it. You know how to factorize the quadratic. Okay, you have to use the middle term splitting method. For the middle term splitting method, you have to break this middle term as the sum of two terms, so that if I add them up, I'll get 4k, and if I multiply them, I'll get the product of last and first, which is minus 60k. So just find those numbers for which this can happen. Okay. So now what are the two numbers for which you can get the product as minus 60k squared and the sum as 4k? So trial and error basically. Okay. So let's find the values. We have 15 and 10 4, no 12. So we can write it as a 6 and 10. Right. Those are the numbers. It takes time sometimes. So k squared plus 10k minus 6k minus 60 greater than 0. Now see, I am just rewriting my 4k as 10k minus 6k because this is 4k again. But the thing is, when I multiply these two, I will get 60k square. So factorization becomes easy. Now take the first two terms, only first two terms, and take out common, whatever is coming out from them. So k coming out from these two. So k times k plus 10 from the first two terms. Similarly, from the last two terms, take out 6 common with negative sign. So it gives negative 6 common times k plus 10. And now you can see there is a common factor in both these. That's why this we splitted this middle term, right? So it is very important to note down this step. We have to split the middle term in this way only, so that at the end we get a common factor out of these. So it is k plus 10 factor out times k minus 6 must be greater than 0. So now we have to find those values of k for which this inequality holds true. What is that? Means this quantity remains positive. This can be positive if either both are positive or both are negative, right? So can I say it is true if k obviously is more than 6? Yes. Or k is less than minus 10. K less than minus 10. Okay. So for these values of k, we will get two distinct real roots. If k is less than negative 10, then both the factors will become negative. If k is more than 6, then both the factors will become positive. So that's the method to solve that. Okay. So that is the answer for the first part. We got the values of k now. Second part says find the possible values of k in these cases where the two distinct real roots are both positive or both negative. This time we just calculated the value of k for which the roots are real and distinct. But now we have to find those values of k for which roots are either both roots are either positive or both roots are negative. So how can we determine those values of k? Our values of k must lie in this interval for getting a getting two distinct solutions. So in these, we have to find those values of k for which roots are both positive or both negative. It means product of roots can be used. Let's see, sum of roots, if I take, let's say alpha and beta are the roots. So alpha and beta are roots of original equation. Okay. So alpha plus beta, if both are positive, then alpha plus beta will be positive. If both are negative, then alpha plus beta will be negative. So it is of no use, right? So sum of roots is of no use. But if I take the product of roots, alpha times beta, when either the roots are positive, both positive or both negative, product will always remain positive. Can you see this? Alpha into beta is always positive. So this condition holds true, right? So now what is the product of roots? Product of roots is given by C over A. C divided by A must be greater than 0. So what is C here? We have C as 15 minus K. So 15 minus K divided by A. A is simply 1. So this quantity must be greater than 0. Okay. 15 minus K must be greater than 0. So this K goes to the other side. So can I say 15 is greater than K or simply K is less than 15? So K less than 15 is the one part of the solution. So in order to have two distinct real roots, k must lie in this interval, and in order to have both positive or both negative, k must lie k must be less than 15. So what is the overall conclusion from this? So we can say our final answer, I'll change a different color. So for our final answer, our k must be less than this 15, but we know it is more than 6 as well. So it is lying between 6 to 15, or k can be less than negative 10. That's always true. Because if k is less than 10, it is always less than 15. So k less than negative 10. This is the answer for the second part. Okay. Now the next part. This one. Consider the function fx equals square root of x squared plus natural log of x plus 4 minus x squared, where x belongs to real number and x greater than 0. And we have to show that the distance L between the origin and any point on the graph f is given by this one, L is equal to this. And in the second part, we have to find the coordinate, x coordinate of the point where the graph of f is closest to the origin. It means its distance from the origin is as minimum as possible. So we have to find the minimum value, minimize, right? We have to minimize the distance. So here you can go for the either first derivative test or the second derivative test. Both are okay to be used. So let's start with this first part. Consider this function and first let's show its distance from the origin. So we already know the distance between 2 points is given by this formula, also provided to you in your formula booklet. Distance is given by that x2 minus x1 whole squared plus y2 minus y1 whole squared. Right? Now, here one point is origin and other point is what? Any point lying on this curve. So x stays as it is and this is the value of y actually. Okay, the fx equals to this square root of x squared log x. This thing is the value of y. Okay, or you can say y1. Now let's find the distance L value that comes out as equals to square root of x2 minus x1. So one point is 0 and other point is x only. So x minus 0 whole squared plus y2 minus y1. Again another point is 0. So y value is what? Original value of the function, which is square root of x squared times natural log of x plus 4 minus x squared. This minus 0 whole squared. So just simplify it. Okay, on this side we will get only x L is equal to x squared inside the square root. Okay, x squared, and on this side it will not affect this 0 will not affect our answer. I have to take the square of this square root of this quantity. So directly this square and square root will get cancelled. Okay, so we get x squared times natural log of x plus 4 minus x squared, where this x squared and negative x squared gets cancelled. This and this gets cancelled. So what we are left with? We got the value of L equals the square root of the remaining part, which is nothing but x squared times natural log of x plus 4. Okay, this is the L, or the distance of that any point on that curve to the origin. Okay, for different values of x we will get different distances. Now that is the answer for the first part. We proved it. Now for B part we have to find the minimum. We have to minimize it, and what is the coordinate of x at that minimum distance, that is to be calculated. For this, as I said, you can go for either second derivative test or you can also find it using the first derivative test as well. So for that we have to take the derivative and put it equal to 0 for getting the critical numbers. So basically the method is dl by dx is equals to 0. If I substitute dl by dx equals to 0, or the derivative of that L equal to 0, I will get critical numbers. So there is one more way actually. Instead of taking the square root and differentiating it also using the chain rule, okay, you can directly differentiate the inner function only, because the minimum value of this x squared log x plus 4 is also at that same point where the minimum value of square root of x squared log x plus 4 lies. Okay, so what you can do is, or you can find the derivative, complete derivative if you want to. So half of square root can be written as raised to the power 1 by 2. Half of this x squared natural log of x plus 4 whole raised to the power what? 1 by 2 minus 1, which is negative half, times the derivative of inner function. Yes, I'm using the chain rule. And in the chain rule, I have to use the product rule now, because we have x squared log x. So use the chain rule, x squared as it is, take the derivative of natural log of x, which is 1 over x, then take a plus sign. Derivative of x squared is 2x, and keep the natural log x as it is. Derivative of 4 is 0. Okay, now I have to put it equal to 0, right? Put this thing equals to 0. Now solve this one for the value of x. So x is not 0 obviously, otherwise it will become what? That point. If I put x equal to 0, log is not defined for that. So cancel out this. So we get x plus 2x natural log of x equals 0. Okay, because this part is also non-zero. Now take x common, it gives x times 1 plus 2 natural log of x equals 0. X is not 0, so leave that part also. We get 1 plus 2 log x equals to 0. Okay, so from here we get natural log of x equals negative half. Okay, now using the definition of the logarithm, I can say the value of x from here must be e raised to the negative half. So at this is critical number. Okay, this is critical number, means where the function can take its either maximum or minimum. So here either you can use the double derivative, you can find the double derivative that I'm leaving for you. Find the double derivative at e raised to the negative half. Okay, and you will find that this value comes out as positive. If this is positive, the distance is minimum. So let's find the x value. What is that? This one. X equals to e raised to the negative half. You just have to show this part also, okay, by yourself, that this is true. Or you can use the first derivative test to show that around this point, e raised to the negative half, left to this, the derivative sign is negative, and right to that point, the derivative signs are positive. So that shows this is point of minimum. You can also show by this. This is your first derivative test, by the way. So you can use any method. Okay. Now, next question, seventh. A discrete random variable x has the following probability distribution. A is positive, k is any constant. K also positive because k is probability of when the random variable takes value 0. So k is also positive. Okay. Now it says first part, show that k is equals to 1/3. In order to find the value of k using this table, we know that the sum of the probabilities associated with this random variable must be equal to 1. So we can simply add these numbers, and this sum is always for any random variable, right? So we have k plus 3k squared plus 2k squared plus k squared equals 1. Now again it is a quadratic equation. What is that? 6k squared plus k minus 1 equals 0. Again, you can use a middle term splitting method. That's up to you, or use the quadratic method. Okay. So let me write it here. We have this quadratic equation as 6k squared plus k minus 1 equals 0. Okay. So split the middle term means writing this k as the sum of two numbers, so that if I add them up I get k, and if I multiply them I will get minus 6k square. So what are the numbers? Yes, 3k and 2k comes to my mind. So 3k minus 2k minus 1 equals to 0. Now take out common. 3k comes out common from the first, so it gives 2k plus 1, and negative sign comes out common, so it gives 2k plus 1 again. This must be same. Okay. Now 2k plus 1 common times 3k minus 1 equals 0. We have two factors, put each factor equal to 0. So from the first factor here, we will get k equals to negative half, and from the second factor, we get K equals to negative half from the first, and from the second factor we got K equals to 1/3. Obviously probability can never be negative, so this part is rejected. This value is rejected, and this value is the answer. Hence we proved that K is 1/3. Okay. Next part. Find the probability when X is less than 3a. So here you have two ways actually to calculate this thing. Okay. One method is that directly finding the sum of all the probabilities for which this X random variable takes less than 3a. So for that K equals to 1 by 3, you can simply add up these. What is that? K plus 3k square plus 2k squared means 5k squared plus k. 5k squared plus k, but you have to substitute k as 1 by 3. So it is 5 times 1 by 3 squared, which is 5 by 9 plus 1 by 3. Now take the LCM and simplify it. So we will get 5 plus 3 by 9 means 8 by 9. Okay. This is the value. Third part. Here you have to use the conditional probability. See, conditional probability of A given that B has already occurred is given by probability of their simultaneous occurrence, means probability when A and B both occur, divided by probability of B. Okay. So here also I will use the same concept for part C. What it says, find the conditional probability when X is greater than 3a, greater than or equal to a, equal greater than or equal to a, but given that X is less than 3a. So it means we have to take the probability when this random variable is less than 3a and more than or equal to a, more than equal to a but less than 3a, divided by the probability given that X less than 3a. Okay, top is what? Combination, intersection or common for both the things. Okay, so now just put up these values and get the final answer. Okay, so what is the probability for more than or equal to a but less than 3a? Means these two, 5k squared, and we already know the value of k also. So basically it is 5k squared, where k is 1 by 3, divided by less than 3a, which we already calculated earlier. Okay, 8 by 9 is the value, but let me write it as 5k squared plus k. So now plug in these values, we got 5 by 9 whole divided by 8 by 9. So 5 by 8 is the answer. Okay, if you still have any confusion in it, you can ask me. 5 by 8 is the answer by that. Probability, sorry, expectation is to be given as 20, and we have to find the value of a. What is expectation? Expectation is mean value, and this time you cannot use your calculator for this. So mean is what? Take the product of fi, right, and divide it by summation of the probabilities, which is 1, by the way. So expectation in this case is given by, just take the product of these two and add them up, these two and these two and add them up, that is your expectation. So 0 times k, which is 0 obviously, plus a times 3k square. So a times 3k square, k is 1 by 3, so I'll write 3 by 9 plus 2a times 2k square, so 2 by 9 plus 3a times 1 by 9. This must be equals to 20 as given in the question also. Okay. Now solve for A only. So this quantity is 0. What is that? A by 3, or you can take the LCM as it is. So we get 3A, keep 9, okay, in the denominator. 3A plus 4A plus 3A whole divided by 9 equals 20. Okay. So what is that? It is 10A equals 180. So A is what? 18. Hence the answer. Okay. A equals to 18 is the final value. Hmm? So in this way, you can calculate the probabilities associated with that random variable. Now, this part. So this is homework question for you. You have to try this question all by yourself, okay? And you can ask your questions anytime directly to me using this contact number given below. And feel free to connect with me for any question. And I'll see you in the next part with few more questions. That's it for today. Take care. Keep watching. Keep learning.